Hey guys, this is Reed here, and this is episode 4 of the Java tutorial series I'm doing for YouTube. So this question is going to be a question from the 2013 regional contest packet, and it is called Maze3D. Now, typically maze problems aren't too bad. This one kind of had a few twists. Now you'll looking at the code after the fact, it really isn't that bad. But when you're solving this in the middle of a contest, it can get a little bit confusing. So I'll show you how I did it, and there might be better ways, but I don't think so. Mine's pretty fast and pretty easy to write. I wrote this in like the last 10 minutes of the contest. So this will probably be pretty good. Right there you just saw I copy and pasted the DAT file. This has one test case of a 4x4 3D maze with that stuff. So okay, I'll go through the question real quick. So dots are empty spaces. The little pound signs are walls that you can't go through. The stars are small debris which you can shoot, because the drone that you're going, basically the question is a NASA like space moon rover type thing where you're trying to go through an asteroid field, and what you have on your robot is a laser cannon that can blow up 3 of the small debris. Well, that's a little bit harder to think about than it is actually to implement, but basically it makes it a little bit more confusing when you actually write the code. Then you also have like the start point and the end point, and that's about it. So it's not that many objects in it, but it is a little crazy. I think the only thing that you could have added to this to make it even harder was like teleportation type squares, which that would have just made this problem quite challenging. So to start off, what you need to make sure you do is you need to have a class level variable that I use a char array or a char matrix that is 3 in length, and it is called map. You also want to have, since the problem isn't just does the path exist, but it wants the shortest path, you need a class level variable for an instance variable for the shortest path, which you're going to start with as integer.max value. That keeps it so that the first thing you find will be the shortest, because it's going to be less than the integer value. And we move on to our for loop. So inside the for loop, not that hard. You want to make sure you reset the shortest path variable to integer dot. There we go. Okay, got that. And then you want to also make sure you get the integers for your rows, columns, and floors, which is what the 3 integers come in there. So they do it a little bit interesting. They start it with rows. So if you don't catch this, you might think it's floors first, which is how the inputs are done. But they just, I don't know, for some reason they gave it to you like this. Row, column, floors, and your input's done in floors, rows, columns. Which you don't have to worry about the input very much. There's some tricks I use to make inputting the data very easy on the coder. And you want to take send.nextLine because you will be reading in entire lines for the next one. This just cleans up any extra integers that got dropped off. So you want to start your map. You need to instantiate it to a map which is a new char matrix of FRC. Floors, rows, columns. That's how maps are done. So then we have the next thing. For int f1 is what I use, but you can use different variables. I guess this would be like ftemp or floor. I guess we'll do floor this time. That seems like a good value. Floor equals 0. Floor is less than f, because that's your actual value you're passing in. And you would do a floor plus plus. Floor is probably not a good value since it's so long, or not a good thing to use in a real contest, but for this it makes it a little bit more descriptive and it's easier to use. So we'll keep the trend using full spelled out names for this, and the shorthand R and F for the other ones, row plus plus. So as you see there, I did not put the brackets around either of my for loops because you really don't need them. It doesn't make sense to add extra little like brackets because it gets confusing whenever you have a lot of them. And you want to keep the code as simple as you can so you can read it and understand it when you're debugging it. If you don't see them, you know that's only going for that exact part. You don't have to worry about extra stuff. It's nice to keep your indentations nice and neat just for debugging purposes, but it's also one of those things that doesn't really ever have to be there. So map floor row, we're going to set to send.nextLine.toCharArray. This will convert everything into a char array, and I'll set it up exactly where it needs to go. Now, if you want right now, you could copy this, and instead of setting it to it, you could just print it. So now I have another one of these. This is what I do whenever I'm in a contest trying to make sure I loaded everything in properly. Print line arrays dot toString of the map floor row. And that looks pretty crazy. Well, not really. It's actually pretty simple, but it may look crazy to you, maybe it won't. But that's basically just going to print out your entire map, which we'll check right now. Everything compiles all good. Let's see if it prints out that like it should. And there it is, nice in array form. You know, the fourth level, that's one thing. 1, 2, 3, 4, another one. And actually, this isn't, is that quite right? Oh, yep, there's 4 of them. Sorry, I just count the things on my input file. So it is, it's actually, there you go. 4 sets of 4 makes your 3D maze, which is basically a cube right now. But the judge's data is actually pretty tricky, but we won't worry about that. That's just something you have to make sure you check different test cases and stuff and make sure your algorithm is properly written. And then we'll do int start floor equals -1 and int end floor, which I guess we'll do, or actually no, int end row equals -1. That is because it may, let me read this real quick. Yeah, I don't think the start and stop, I mean, if you read the question closer than I am, you will probably be able to find out exactly, but I'm pretty sure the start and stop don't always happen in the exact same positions, which makes it easy, or not easy, but makes it harder on you to write. And we'll do start call too. Start column, SC, and then we'll name our loop. So what we have to do is we have to find where the start is. Now, what you're doing with this is just going to loop through for int floor equals 0. Basically, you're going through everything again. F is less than F, F floor plus plus. Do the same thing. Row equals 0. And then row plus plus. And this time you actually do have to include columns because you're not sure which column it's going to start in. And there we go. Nice and pretty, and not really pretty, but it works. You need an if statement. So now let's check if map floor row call. So all of them, that's why it looks crazy. You have like 3-level matrix and you have to make sure it's all good. If that is equal to the S character, capital S, you know you have to do the other stuff. Why is that brace in the middle of nowhere? I'm not sure why that's there. It's for my run count loop. Then this one you do need to include braces on your if statement just because you have a lot of commands. So you need to start the start floor equals floor. You need to check the start row equals row, and you need the start column to equal column. And you also don't want to have to waste time going through the loop because you're definitely going to have issues with efficiency, where you might not have issues with efficiency, but it's always better to make sure if I find it, I don't need to look through it again. It's never going to find it again. Let's just break out of the loop and keep going so it's faster. And all the way back over to the right indentation. So pretty simple now. We're going to call recur, which is going to return a void type of start floor, start row, start column, 0 for the distance it's traveled, and 3 for the amount of lasers it has left to shoot. So the method, I'll just fill that in right here, is going to be a void called recur. You can come up with better names. I typically use recur just because that's how I've always done it, and that's how I'll keep doing it. And you have int steps, and you'll have int laser, like that. So we'll fill that in a minute, but for now let's go back to the next part. So after it recurs, what you'll notice is the shortest path will be equal to the distance it's traveled. However, there are going to be cases where it might get stuck, as in there's no shortest path available. Well, what you know is that if the shortest path is equal to the integer at max value, then it will be shortest minus 1. That means if it's equal to it, that means it doesn't find the maze, so it's going to be stuck. And the reason I have -1 there is just because how I write my recursive things, it always has an extra 1 added to it because I return it with it. And I always count like the step it took, the first one to get off the start plate counts as 1, which typically doesn't. So you may or may not have to add -1 there. If you do my code, you will have to. It just always happens like that. It's okay. As long as it's like 1 off every time or whatever, you just get used to it and you just put -1. And if you don't find it, you put stuck. which this happens if it is equal to integer.max value. So that is your entire actual main loop. Now for the recursive part. What you have to do first is you have to check your boundary conditions. Always, 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 that's the first thing in your recur loop. Just check boundaries. So if f is greater than or equal to 0 and f is less than map.length and, not that, and row is greater than or equal to 0 and row is less than map f.length, you will have to do it like this where it's map f.length. You could do map 0.length, but sometimes that doesn't work, especially if it's not an exact cube or something like that. So I would prefer just to do map f.length because you already checked f to see it's inbound here. So you know it's going to be inbound already because this two and signs enables the short circuiting in Java, so you won't have to worry about it ever being out of bounds here. Then you do the same thing here, call greater than or equal to 0, and column is less than map f r.length. So you know, yep, my little character is in bounds. Now, because you are going to be calling a bunch of calls to the actual like recursive method, and you have to refer to the character that is in the map frc square. What I did to make this easier on myself is I just made a char like this, char cc for character, something like that, char temp, let's do test, equals the character at map frc, like that. There you go. Char test equals map frc. So right there you have the character and you already referred to it. Now since you're in bounds, you can also increment your step count right here. That just keeps it going. And then if test is equal to the start, we get to do now. So you have to do this for every type of character it could land on. You have to have a separate if condition statement to see how it's going to handle it. Well, the first thing you want to do is you want to make sure that it sets that character, map frc, to a null condition character, which I use a dash. That means I've already been there. I don't want to recurse over this spot again, otherwise you'll get some infinite recursion stuff. Then the fun part. There are 6 different directions the robot could go every time, or not robot, but the moon rover thing could go every time you do it. 6 is a lot. Typically in recursion you have 4. If you have diagonals, it's even crazier, but we're lucky they didn't make us do diagonals in 3D. It's only 6 conditions. So you have the 3 basic conditions. You have f minus 1, rc, steps, laser. Right there, pretty simple. You have f plus 1, which means if it's going up or down a floor. You have f and then r minus 1, c, steps, laser. You have fr plus 1, c, steps, laser. You also have the column, so it's changing column, frc minus 1. And you have frc plus 1. Pretty simple, not really, but it's somewhat simple. Then you have to, once you finish recurring through all those, you want to reset the map back to what it was originally. So you set it to S, like that. And that covers your first condition, which is the one if it's the start. I usually do these in the order that they're going to be countered in the code or just some other arbitrary order. It doesn't really matter. Else, what happens if you land on a character that is equal to the star, or the little multiplication sign thing? Well, you also have to make sure that the laser is greater than 0, because if the laser is not greater than 0, you'll end up not having lasers to shoot it, so you can't go there and it treats it like a actual block that can't be passed. So we go like this. Map frc is equal to the null condition, which is our dash. And then you do laser minus minus because you want to make sure that laser is decreased properly. And since we have this already written up here, it's pretty simple. You can copy and paste it. And because you're doing all the conditions and changing stuff inside there, just copy and paste. And, oops, add an extra D. And there you go. You got it in that one. So you also have to remember to reset everything once you're done. RC equals the star. And you don't need to worry about doing the laser minus minus because laser and all those things are not passed like objects by reference. They're just by value because it's an integer. So you don't have to worry about doing any reset for the laser thing. Now let's see what happens when the character is a period. That means it's a free space. So you can basically do the exact same thing. frc equals the null condition. We always use dashes. And copy and paste. And reset it once it's done. like that, equals like that. Okay, now the last condition. So those are the first group of them. You don't have to write a condition for the pound symbol because that's just not going to happen. So you just, if it doesn't hit the if statements, you don't do anything. But there is one more. What happens when it's finished? So if the robot is at the end, so if test equals E for end, then we have to do the checking of the shortest. So let's see, if steps is less than shortest, we can set shortest to steps. Pretty simple. And then it will just get out of the loop, and since there's nothing else, it'll automatically return. And there you go, you're done. So this should make it work. So it's 3 levels of recursion, 6 levels each. The hardest part about this problem isn't really writing the code, because once you write the code, you kind of know what you're doing. Ooh, that's not good. Oh, changed my values to row, col, C. We gotta fix that. If R, I don't know why I did that. I never do full names in these. Interesting. And there we go. Now it compiles all pretty. We run it, and it gives 9 moves, which is correct. Now you can get, I actually don't have the judges data for this one, but I can't really show it to you. I will get rid of my print out the maze thing and make it look, oops, not good. Compile. There we go. And there it goes, 9 moves, just like the judges output, or the sample output. The judges data work with my code. This is exactly what I used, I'm pretty sure. Very, very similar, just the traditional maze algorithm. You just have to make sure you keep track of your laser and going different levels. So once you kind of know how to write a simple maze, this one is easy to do. You just have to make sure you know how to write it originally. You just have to think about it, okay, how am I going to treat each thing? How am I going to treat going up and down? How am I going to treat keeping track of my laser? I did it all through just passing it as a method. There's some other ways you could do it, I'm sure. Just a simple check bounds, get your character, test the character, set it equal to something you don't want it to be ever found as, recur through everything, and then reset everything after you're done. Very simple, and it works quite well. So this is actually a very long 17-minute video, so I'm probably going to have to see if it can actually upload it to my YouTube channel. It might only be on the Houdini Vids channel, or I might be able to get it on my other YouTube channels as well. Anyway, thanks for watching, and I'll see you on Monday with a new problem. I'll probably choose another one out of the Regionals 2013 packet because that was a fun packet to do, and it was lots of interesting and challenging problems, which are good to learn from. Thanks for watching, and I'll see you next time.